Now let us study the next important measures of dispersion, which are variance and followed by the standard deviation. Now first let us see the variance. As shown here on the slide, variance is defined as 1 upon n summation xi minus x bar the whole square, or that is also equal to 1 upon n summation of xi square whole minus x bar square. This formula apply for the raw data. In case of discrete and continuous data, you see that there is just addition of one factor of fi, as we have seen in the previous formula. Okay, so apart from that, the rest of the terms are exactly same as raw data. Now you may wonder from where these two formulae come, that is how they are equal to each other. So let us derive them. Let us see that both are merely two different forms of the same formula. Right? So we go ahead and prove the relation as shown here. Right? So let us start off from LHS. LHS is 1 upon n summation of, let's prove it for raw data the same way we can prove for discrete and continuous. Now here we open the square inside the summation. So on opening the square by a minus b the whole square, we have this particular expansion, correct? Now as per rules of summation, we can break the individual term in different summations. So let us write it as 1 upon n summation xi square minus 1 upon n summation 2 times xi x bar plus 1 upon n summation of x bar the whole square. Now 1 upon n summation of xi square, the first term remains unchanged. You see that we have already obtained the first term on the right side, so we will not touch it now. Minus, now in the second summation, if you see 2 and x bar are constants from the perspective of summation, because for a given data x bar whatever it is will be nothing but a constant term, isn't it? So therefore we will take 2 and x bar outside the summation, and we will have 2x bar into 1 upon n summation of xi, right, plus similarly x bar square will also be treated as constant, so therefore we will have x bar the whole square into 1 upon n summation of 1 remains inside the summation. So this is equal to 1 upon n summation xi square minus 2 x bar. Now if you look at this particular term carefully, 1 upon n summation of xi, isn't it sum of all observations divided by n? So that is nothing but equal to x bar only, plus here we have mod x bar the whole square. And if you look at the last summation, that is 1 upon n into summation 1, we know that summation of 1 done n times is nothing but n, so therefore that will get cancelled with n, leaving only x bar the whole square at the end. Therefore we have 1 upon n summation of xi square minus 2 times x bar square plus x bar square. So therefore we merge the last two terms because they are the like terms, and hence at the end we get 1 upon n summation of xi square. See, this term is separate, minus we have x bar the whole square, and that is nothing but the RHS. So therefore we have proven the required relation. Now it is important to understand in which situation we use the form on the left hand side or form on the right hand side. That is, how do we know which form to use? See, because both of them are going to give us the same final answer. So the answer to that is, if the value of x bar is a simple term, say a round figure, isn't it? So in that case we can go ahead with subtracting it from every observation, that is xi, and then doing the square. But often the x bar could be having some decimal part also, some fractional part. So in that case the left hand side form will not be convenient. So in that case we have to go with the right hand side form, which is slightly more convenient from calculation point of view. So this thing is to be kept in mind while solving the sums based on variance. Now we move on to the last most important measure of dispersion, that is standard deviation, denoted by sigma. And as you see here, it is defined as the positive square root of the variance, right? So by convention we take the root to be positive. So we have already seen the formulae of variance. Once we take the square root of them, we get the standard deviation.